Welcome Year 12s to this video. What I'm going to do in this is take you through an introduction to deseasonalizing. So what we will be doing just for this last part of the topic, last part of our data analysis, is just focusing on seasonal data only. So with our time series so far, we've looked at the different types of time series, the different trends and patterns that can occur, and we've worked on smoothing those time series as well. Now, seasonal indices, or the act of deseasonalizing data, is going to do a very similar thing to what smoothing does, in that it's going to try and take out some of those like wavy parts of the data. It's going to try and it's going to, I guess, attempt to show us whether there's any underlying trends. So by deseasonalizing, what you're trying to do is you're trying to take out the seasonal component of the data. Before we do start looking at deseasonalizing, however, we need to know what a seasonal index is, or what seasonal indices are. So that is going to be the purpose of this video, just to give you an introduction to the deseasonalizing component. Before I move on, I just wanted to mention that when I'm talking about seasons, I'm not necessarily talking about summer, autumn, winter, spring. It's not about that. Seasons, of course, when we look at seasonality, we weren't really looking for whether there was, say, peaks in the summer or peaks in the winter. We were looking for just consistency within a year. So when I'm talking about seasons, they can apply to any time period really at all. So this could be days, could be weeks, months. One of the popular ones you'll come across is quarters. So here's an example just to the right here of some seasonal data. You've got daily hamburger sales, and as you can see, there is a trough every Tuesday and there is a peak every Saturday. So that particular data is taken daily. So what is a seasonal index? When you are looking at an index, when you're looking at indices, that's the plural, you are looking at a particular figure, and it's a figure that you're going to be calculating based on the data that you have. So it's a calculated figure, and it's telling us, or it's giving us a comparison. It's giving us how a particular season, so say it's a day of the week or a month of the year, it's telling us how that compares to the average for that whole cycle. So the average for the week or the average for the year. So what we will be doing a lot of is first calculating the average, the seasonal average we'll call it, and then using that to get this thing called the index. Now, just a couple of things about them. When you calculate them, what you'll see is that they're usually close to 1. So they'll be either slightly over 1 point something something something, or they'll be slightly under, so 0 point something something something. Sometimes they'll be exactly 1, and I'll tell you what that means if you get an index of exactly 1. There's something really special as well about them, which allows us to ask you some questions, particularly multiple choice questions, which I'll get to, and that is that the average of the seasonal indices, that will always be equal to 1. So if you have a particular data set, you look at the indices within that whole cycle, they'll have an average of 1, always. The other interesting thing, which links very nicely with the average, of course, is that the sum of the seasonal indices, it's always going to equal however many seasons you have in a cycle. So as an example, if you're working with monthly figures, there's obviously 12 months in a cycle, or 12 months in a year, so the sum of those seasonal indices will always be 12. Quarterly, which we're going to look at a lot, that will always sum to 4. Fortnightly is not as common, but there's 26 fortnights in a year. That's something you're going to need to know for your for financial modelling, which we'll do in term 2. So that's one that you need to commit to memory immediately, 26 fortnights in a year. Daily, if you're just working Monday to Friday, obviously 5, and 7 for a full week. So if we have a look at this one here, we've got a two-monthly period, so January, Feb, March, April, May, June, etc., over the year 2005. And we've got the seasonal indices written underneath. So in this case, because it's just over, every season is a 2-month period, you actually have 6 seasons in the year. If you add these up, now these have been rounded off to 3 decimal places. If you add them up, you get something like 5.999, which of course, when you round it, is equal to 6. So when you add them all up, you should get 6. This means that if you want the average, that's obviously going to be the sum divided by however many there are. It's going to be, the sum is 6, so 6 over 6 is 1. And I mentioned that earlier, that the average of the seasonal indices will always be 1. Excuse me. So what do they actually mean? Here we have another set of data. This is from summer, autumn, winter and spring 2015. And we've got the seasonal index of each season written underneath. So what you'll see here is that there is one that is exactly 1. I said that can happen. These two here are slightly over and this one is under. So what does this seasonal index of 0.6 actually mean? What it means is that just by looking at the 0.6, I know that summer is below the average. So if you're looking at seasonal indices that are below 1, what you're looking at are figures, or the data itself for that particular season is below the average. We can even see it as a percentage. It's 40% below the quarterly average. Now, how do I know that? Well, if you go 1 minus 0.6, means that it's 0.4 below the average. Excuse me. So it's 40% below. If you have anything that is over 1, this obviously means that it's higher than the average. So below 1, lower, above 1, higher than the average. And if you look at how much, what proportion it's above, it's 0.3 above 1, which converts, of course, multiply it by 100, to a 30%. So 1.3 means that that figure for autumn, the data for autumn, whatever it was 30% higher than what the quarterly average was. Likewise, 1.1, that's 10% higher. And spring, because it is exactly 1, means that the spring data was exactly the same as the quarterly average, or it matches the quarterly average. So just in summary, for a seasonal index, if you have an index that is below, you want to look at how much below 1 is that index. So for this one, 1 minus 0.85 is 0.15, which as a percentage is 15%. So it's 15% below the seasonal average. A seasonal index of 1 matches, and of course, when they're above, they're a little bit easier. 1.23 is clearly 23% above. So where do they come from? How do we calculate them? What you want to do is you're always working with the seasonal average, because of course the seasonal index is giving us a comparison to the average. So the first thing you'll be doing always is working out what the seasonal average is, and then you will take the data value for that season and you'll divide it by the seasonal average. Now, what this means, of course, is if you have a data value that is higher than the seasonal average, when you do that division, you're going to get a number above 1, which is what is expected. And if you have a number that is lower than the average, you're going to get a value, an index less than 1, also what's expected. All right, so let's have a go with this one here. We've got 2005 data. There are the 4 pieces. It's clearly quarterly data. What we want to do is first find the average of that. So the seasonal average is going to be 950 plus 1115 plus 1270 plus 485, and that's divided by 4. So grab your calculator out. You can do this as well. I'm going to quickly do it now on mine. And we get 955. Okay, so that was our seasonal average. Now what we want to do is get the seasonal index for each of these quarters. So for quarter number 1, what I'm going to be doing is taking the data value, which is 950, and dividing that by the average, which is 955. So we'll do that now. So you can see it's going to be close to 1 because the numbers are almost the same. Now I'm going to go to 3 significant figures, or decimal places here actually. 995. So 950 divided by 955. It was 0.99476, etc. So I've just rounded that one off. Of course, quarter 2, I'm going to do the same thing, but with this value. 1,115 divided by 955. I've got 1.168, rounded to 3 decimal places. Now do the same with the other two. You'll see these ones here were above the average, so as expected. Now this was 1.3298, so it went to 1.330. This last one's quite a bit below the average, so of course this means it's going to be quite a bit below 1. 508. Now we have rounded a lot of these up just because of rounding. It means that when we do add it up, and you can do that now if you like, might be slightly over. When you add it up, you'll get 4.0. Now, I remember I mentioned they'll add up to the number of quarters. Now, this 0.001 that we've got tagged on the end here, it's just due to rounding. Okay, so don't panic about that. Just like the one I did before, it summed to 5.999. It's only because of rounding. Okay, that's how we calculate them. So not too bad. Seasonal average first, and then of course you go original data value divided by that average. Sometimes, however, you might have multiple cycles, so you might have data for more than 1 week or more than 1 year. And what we do then is we actually take an average of those individual seasonal indices. So what I mean by that is if you have a look at this, I've already calculated this for a lot of it. There's our original data. We've got Monday, Tuesday, Wednesday, etc. But we've got it over 3 separate weeks. So to get these values in here for each day, I would find the average for week 1. Then I would go 8.7 divided by the average for week 1, and then I'd get 0.83. I'd go 9.4 divided by the average for week 1, and I would continue. To do week 2, I'd obviously be working with the average value for week 2 rather than the average that I found for week 1. So what this means is you've got different indices for different days. So if you need an overall seasonal index for a particular day, you actually need to average out for this one, 3 days worth for Monday. I just need to find the average of those 3. So what I'd like you to do now is grab your calculator and obviously add the 3 for each day, add the 3 indices for each day and divide by 3. Now I haven't left you much space here, so we might just need to round to 2 decimal places, like these ones are rounded to anyway, so do just be careful with your rounding. So 0.82. There are decimal places after that, but I am rounding this off. The next one, 0.9 plus 0.85. So you might like to do this yourself and then just skip this video ahead just to check you've done the same as I have. So 0.919594 divided by 3. So you see these ones were all below. So when you've got some below, you obviously need to have some above as well so that they do actually average out to 1. So that one's also 0.93. And this is where we're starting to get values above 1. So 1.02 average, and we've just got 2 to go. So 1.11, 1.14, 1.12. It comes out as 1.12 and rounded. And finally, it looks like Sunday has the largest values, 1.31. There we go. Okay, so remember, they should add up to, when you have seasonal indices, they should add up to the number of seasons. So just a reminder about that. We're going to have a go just calculating an overall seasonal index. So that's where I've done it for the overall for the 3 weeks, but we've got some different data here. This is monthly data down here. So you might like to pause it and have a go yourself and then check back or skip ahead and do it. Otherwise, you'll follow along with me. So the first thing I'm going to do is I'm going to get the average, the seasonal average for 2004 and for 2005 because I'm going to need them. What I need to do here, because I just need it for February and for December, is I'm going to find 2 seasonal indices for February, one from 2004 and one for 2005, and the same for December. Then I'll just take the average of those 2. So, the most time-consuming part here really is finding the average, because what I'm going to have to do is add up all those values for 2004, so 29, 28, 30, 29, 31, 35, 34, 33, 29, 28, 27, and 31, and then divide that by 12. Now I'm not going to round it off. It comes out as 30.33 recurring. I'm just going to leave it in my calculator like that. On here, I'm going to put dot, 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 just to indicate I'm not rounding that off. I can't round anything off until my final answer. Otherwise, I change the result. Alright, now the second one. Hopefully I haven't forgotten any values here. 366 on 12. So that one comes out as 30.5. So that works out well. Okay, so for February, for the SI for 2004, so here it is here. It's going to be the value, which is 28, divided by 30.33 dot, 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 which is, now I'm just going to use the value that's in my calculator and enter it down. And I might go to 3 decimal places here. So 0.923. It does continue, of course. And then I'll just split this in half. 05 will be 27 divided by that average, which was 30.5. So 27 on 30.5 comes out as 0.885. Dot, dot, dot. And then, of course, I find the average of these. So I add them together, divide by 2. Overall, just in your calculator now, I'm just going to enter them down because I've got them in my calculator screen already. I've added them together. Now divide by 2 and I get 0.904. So there's the overall seasonal index for February. I'll do the same thing now with December, just quickly. So December down here, 31 divided by the average for 2004, which was the 30.33 dot, dot, dot. For 05, 30 divided by 30.5. And then I'll do the overall after that. Okay, so In your calculator, 31 divided by, and again I've got that seasonal index saved, so I'll use the one in my calculator. I get 1.022. Well, actually, I'm not going to round it off yet. So 1.021 dot dot dot, and then I've got 30 divided by 30.5. 0.983 dot dot dot. Add them together, divide them by 2. So I've got them on there. Just lost my little addition. There it is. And divide by 2. Okay, so this one comes out as 1.003. So very, very close to 1, which is expected because 31 and 30, of course, are just either side of that average there, and just a little bit higher, or very close to this average here as well. So as expected, the December one was very close to 1. The February one, both of those values were below the average. So as expected, SI, or the seasonal index, is below 1. Just before I finish, I just wanted to show you a couple of examples. These are really common ones that pop up where there's a missing seasonal index and you need to find it. Then, of course, in our next lesson, we'll have a look at deseasonalizing. So what we actually use these seasonal indices for. So to answer questions like this, typically what you want to be able to do is remember that the sum of the seasonal indices will always equal the number of seasons. So here with quarterly data, you have 4 seasons. So this should sum to 4. So what you want to do is add these up. So I've got 1.08 plus 0.96 plus 1.34 is equal to 3.38. So if I go 4, I'll just do this here, minus 3.38, I should, of course, get what's missing. So I should have what belongs in here, which is 0.62. Now, of course, they're not always going to sum to 4. If you've got this here, you see, again, 2-month period, so 1, 2, 3, 4, 5, 6 seasons. This should then, of course, sum to 6. Whoops. So what we do is we add them up. So 1.36, 1.01, 0.96, 0.95, and 1.22. We get 5.5. So if we go 6 minus that, we should have 0.50 for May. The last one, of course, is a little bit annoying because there are 12 of them, and of course we need these to sum to 12. So nice and quickly, let's add them all up. Alright, I got 11.35, and of course if we subtract that from 12, so it's going to be 12 minus 11.35, should get 0.65. Belongs in there. Okay, I will leave it there. So that's your little introduction to seasonal indices. So remember, the sum of those indices will equal the number of seasons. To get an overall seasonal index, you need to take the average seasonal index for each season. The seasonal index itself is equal to the original data value divided by the seasonal average. And remember, if you've got a seasonal index below 1, it means that the data is below the seasonal average. If it is above the seasonal average. If it's 1, it matches that average. And just bringing back to the beginning, the reason that we do this is we're actually going to take out that seasonal component. So we are going to de-seasonalize, which is what we're going to use the seasonal indices for when I see you next.